Algebra II 3.6b Slope-intercept equations of lines. If you haven't seen the previous videos for Chapter 3, you might get confused. This is 3.6b. There was a 3.6a before this, and you can click on this video's description to go right to it. If we know the slope and y-intercept, we can find the equation for the line. So if we look at this line, we can see the slope. The rise is a 9 and the run is a 3. That's 9 over 3. 9 divided by 3. The slope is a 3. See? And the y-intercept right here is this -8, isn't it? See that? It's down here. So we've got the slope of 3 and the y-intercept of a -8 down here. See? A negative of 8. From the point slope equation, this equation right here that we've been talking about in the last couple videos, we can plug these values in. We'll use a 0 for x if we don't know what x is, and we'll have an ordered pair of 0 and -8. Plug it into this point slope equation, and we get y minus a -8 equals 3x minus 0. This is going to make a positive, isn't it? When you subtract a negative, you add the opposite, so we have y plus 8 equals 3x minus 0. And this 0 is important because when we create a 0 pair here by adding a -8 to each side to isolate this y, that puts the -8 right here. See? We get y equals 3x minus 8. That puts it into slope-intercept form. That's the slope-intercept equation of a line. So we changed it from this equation to this equation just by substituting in the values and using additive inverses. See? So I have a theorem for you. The slope-intercept equation says a non-vertical line with slope m and y-intercept b has an equation y equals mx plus b. And here's the m, the slope. That's the y-intercept. That's b. That's where it hits the y-axis. We can use any equation of a non-vertical line to find the slope-intercept equation by solving for y. We just set it to equal y. Now there's no slope-intercept equation for a vertical line because the line has no slope. A vertical line has no slope. It's undefined, isn't it? So in this equation, y equals 2x minus 3, we can see just from looking at this equation, we know the slope and where it's going to hit the y-axis. It's going to hit it at a -3. See that? It tells us right in the equation. M is 2 and b is -3. See? We can find the slope and y-intercept of the line whose equation is written in standard form. We're going to talk about this a little bit more in the videos coming up, standard form. But if you look at this and compare it to this formula for a standard form, we've got 3x, there we go, ax, and minus 6y, well, that's like by, and they've stuck in this little extra, didn't they? And it's going to equal c, but it's still in standard form. And we can find the slope and y-intercept of this equation by solving for y. So we need to do additive inverses to get this y on the other side of the equal sign, don't we? This will put the equation into slope-intercept form. So here's the equation, 3x minus 6y minus 7 equals 0. We're going to add a 7 to each side, and it's going to create a 0 pair right here, right? It's going to get rid of this. He's gone. And now we've got 3x minus 6y equals 7. We still need to isolate this y, so we can add a -3x to each side. You can look at it as subtracting the 3x or adding a -3x. It's the same thing. And positive 3x, take away 3x. Another 0 pair, using the addition property of equality, right? And it's going to take away a 3x from this side. We want our terms to be in the right order, so we're going to put him first because he belongs first before the 7. So now we've got -6y equals a -3x plus 7 on this side, and I'm dividing by this coefficient -6, -6. Now the multiplication property of equality says that we can multiply each term by the reciprocal of that coefficient, this -6, as a -1/6 by writing it as a fraction as 6 over 1 and then flipping it around. Or we can just divide each term by a -6. Because there's no fractions, it's easier to divide in this case. We don't change the sign for the reciprocal. If the coefficient is a negative, then the reciprocal is going to be a negative. So if this were a fraction, this -6y, like if it was 6/10, then yeah, it helps to do it by the reciprocal, because then you're just multiplying the numerator across and the denominator across. But when it's not, when it's just a -6 like this, we could just divide each term by that -6. And it gets us straight away into a y, because this negative and negative makes a positive, and that makes our buddy the invisible 1, doesn't it? And -3 over -6, -3 divided by -6 gives us a positive half x, and this positive and negative makes a negative, so we have -7/6. Now, I also could have written this as, see this -3x plus 7? I could have gone -3x plus 7, and I could have just put 1 bar and put the -6. Some people do that, and they just write this as the positive half and this as the -7/6. See? This is easier on the eyes when you're first starting, just doing it by each term, okay? Make sure you do it by each term. All right, so now we've got this y equals half x minus 7/6. We can see that this is our slope. It's a rise of 1 and a run of 2. And our y-intercept is going to hit at -7/6. And this is written in slope-intercept form. We changed it from standard form, like this, into the slope-intercept form by using additive inverses, okay? So m is a half and b is a -7/6. So I made this chart, this Cartesian graph, that has 6 units before it becomes a 1. See? 6 units before it became a -1. That way I could do the -7/6. So 1 is 6/6, that's 6 squares, and here's 7th square for 7/6, okay? And we need a rise of 1 and a run of 2. Well, because these were such tiny squares, I did 6 and 12, because that makes 1 over 2, doesn't it? But then it's easier for my eyes to see, okay? So just remember that if you do multiply by the reciprocal, you do not change the sign, okay? So if it's a negative, you multiply by a negative reciprocal, okay? And if there's no fraction, you don't need to use the reciprocal. You can just divide each term, all right? And change the equation from point-slope equation into slope-intercept, like we did over here. Or change a standard form equation into the slope-intercept form, all right? Our next video is 3.6c, and we're going to graph using slope-intercept form. You can go to the Algebra II playlist in this video's description to catch up, review, or study for tests. And there's going to be a link to the Algebra I, Chapter 7 playlist for graphs and linear equations. And there's going to be links to that previous video, 3.6a, that we just finished, okay, in case you missed that one. All right, I'll see you next video, and I hope this helped, and I hope you're doing well. I hope you're having a great day. Bye.